Assalamu alaikum. In this series, Mr. Omar will guide you through some practice problems to cover all items included in the coverage issued by Emirates Schools Establishment, E.S.E. This is part 4. Have a fruitful time.
Assalamu alaikum warahmatullahi wabarakatuh. Welcome to part 4 in our recovery for the exam. Now we are in the goal number 16. Question number 1. Which one of these two graphs represent a copper wire? You know that the copper wires obey Ohm's law. So it is a linear resistor. That means the graph should be a line, a straight line. So the answer is the left one. Here it obeys Ohm's law at the beginning, but for larger amount of V, it will not obey the Ohm's law. So in general, it will not obey the Ohm's law. Give some examples on ohmic and non-ohmic resistors. For ohmic, you know that metallic wires like copper wires, aluminum, silver, and so on. And you have tungsten. And carbon resistors. For non-ohmic, you have diodes, lamps, solutions, like salt solutions or ionic solutions, and so on. You can go to your book and find some examples. It's very important to get some examples from the book, okay? Now, question number 2. Using the circuit shown, a student performs Ohm's law experiment and she gets the following data. She writes V and I. As suggested by the table, the independent variable is V. So it should be assigned to x-axis or the horizontal axis. And the dependent variable, it is I. So it is in the vertical axis. Now represent this data on a graph paper. Draw the best fit line. We need to draw the best fit line. They make attention in the coverage about drawing graphs and best fit lines. So please study this question very well. Then find the resistance. After that, if the actual resistance was 50, justify the error in the experiment and find the percentage error in the experiment. How can you reduce this error? Okay, let us start by representing the data. First, we need a graph paper like this and put the x-axis and y-axis or the horizontal and vertical axis. It's better to say horizontal and vertical instead of x and y. This is the horizontal axis and this one is the vertical axis. This is the independent variable, which is the voltage in volt, and this axis represents the dependent variable, which is the current in milliampere, so times 10 to the minus 3 ampere. Don't forget this factor. Okay, now for the voltage it is equally increment 2, so I can put every 10 small squares as 2, so it is 2 volts, 4, 6 volts, 8 and 10. But for the current I must be very careful. I cannot put 40, 80 like this, 40, 80, 110, 160. No, it's very wrong. Instead of that, try to find the maximum value. It is 210 for the current. So it is a multiple of 3. One, 2, 3, 4, 5, 6, 7, 8, and 9. Multiple of 3, so I can put 30 all the way, 60, then 90, then 110, 20, 150, 180, 210, 240, and so on. Now put your data on the graph. 2 voltage and 40 milliampere for the current. 2, here is the 2. Here is the 45, so 40, it's maybe something like there. Now 4 and 8, 80, 4, this is 75, 80, it is somewhere here, and so on. So assign your data on the graph. I will put them carefully and I will come back again. Take your time to draw the data by your own. If you follow these points, it is not in a best fit straight line, so you need to draw the best fit draw line. Be careful, this is question number 16. It is based paper question, it is not multiple choice question, so you need to draw by yourself. Take your ruler, pencil, and so on to the exam with you. Now I want to insert a straight line to represent all of these data. Okay, it's a very wrong line, but I want to teach you how to now this is my line. It is not a best fit. Why? Because it is, yes, it is passes through 0, 0. It passes through 2 points, but the other 3 points are below it. So try to slope the line as if it passes through many points, and the points below it, number of points below it equals almost the number of points above it. So also this is wrong. This is better. We have points on the line, the first one and the fourth one, and we have this is better than the first one. We have 2 points up or over the line, but it is very close to the line, and this is far away somehow. So I think it is the best fit line. Now, if you find the slope of this or the gradient, delta vertical over delta horizontal. So the slope equals, take 2 points on this line. This is the most convenient one. It is 0, 0. Take another one which is, it does not need to be on in the table. It needs to be on the line, but I find this satisfies the line and the table as well. It is 8 with 175. Don't forget, this is milliampere and this is volt. So the slope is 165 minus 0 times 10 to the minus 3 because it is milliampere, and 8 minus 0. I took these 2 points. So the answer is 0.020625. It is ampere per volt. If you notice that this is delta I over delta B, which is 1 over R. So the resistance is 1 over the slope. 1 over 0.020625. So the resistance for this circuit is 48.5 ohms. Now let's go back to the question. Represent these data. We represent it. Draw the best fit line. We draw it. Find the resistance of the circuit. We found it by the inverse of the slope. Now, if the actual resistance was 50, justify the error in the experiment and find the percentage error. How can you reduce it? The error comes from the temperature. As temperature increases, the resistance increases. Why the temperature increases? As the voltage become higher, then the resistance, the temperature is increased. That means increasing in the resistance. How we can get over that? To reduce this error, switch the circuit every time you take a result to keep the circuit in the room temperature. Now the error I supply as E equals the absolute of real minus experimental values. The real is 50 minus the experimental, it is 48.5, it is 1.5. Now the percentage error is E over real times 100%. 1.5 divided by the real times 100%. The answer is, I think, 3%. So it's a very small error. Now for goal 17, we want to deal with the equivalent resistance for complex circuits. Find the equivalent resistance between points A and B in the following figure. First, where is A and B? Here A and here is B. So we need to find the equivalent for the all. It is such an easy circuit. Why? Because we have here R1, here R2, R3, R4. First we have R2 with R3 in parallel. So they will equal R5 مثلا. R5 equals two resistance in parallel multiplication over addition of them. So 2.5 multiplied by 10 over 2.5 plus 10, 25 over 12.5, it is 2 ohms. Now the resistance between A and B is R1 in series with R5 in series with R4. R1 it is 4 times R5 2, R4 9, it is 15 ohms. Calculate the current and potential difference for each resistance. Now the current through 1 is the same as through 5, same as through 4, which is the same between A and B, which is V over RAB. Now the potential difference between A and B is 36 as mentioned in the question here, and the resistance is, the total resistance is 15. 36 divided by 15, which is 2.4. Now we can find the voltage for R4. I times R4, 2.4 times 9, it is 21.6. V for the first resistance, IR1, 2.4 times 4, which is 9.6. And V for R2 equals V for R3 since they are in parallel, and it is the same as V of the resultant of them or the equivalent of them, which is R5. So it is I times R5. I it is 2.4, R5 it is 2, so it is 4.8. Or you can simply find V2 and V3 by subtracting 21.6 plus 9.6 from 36. Why? Because they all add to 36 volt. Can you find the voltage without finding the current? Yes, by using potentiometer. VI equals RI over total R times V. So V1 equals R1, which is 4, divided by the total resistance is 4 and 2. This is 2. That is the equivalent of 2.5 and 10. It is 2. So the summation is 4 plus 2 plus 9. 4 plus 2 plus 9 times 36. And it will be 9.6 volt. For V4, it is R4, which is 9, divided by 4 plus 2 plus 9, multiplied by 36. So it is 21.6. And V2 equals V3 equals V2 V5, so it is R5 2 over 4 plus 2 plus 9 times 36, which is 4.8 volt, the same as mentioned. For the circuit shown, find the equivalent resistance and current passes through the resistor 3 ohm. Go far away from the battery. Here we have two parallel resistors. How we decide that? Imagine the current is flowing from the battery. It will go through 2 ohms, then it will split it into 3 and 1. Here, because we have splitting of current, so we will not say there is a series. Is there a parallel? Maybe. If the 1 ohm and the 3 ohms have the same beginning and same ending, so they are parallel. This point is the beginning of 1 ohm and 3 ohms. This point is the end of 1 and the end of 3. So they have the same ending and same beginning. So we can say that these two resistors are in parallel. What is the resistance of these two? How much is that resistance? It is the multiplication of them divided the addition of them. So it is 0.75. 3 times 1 over 3 plus 1. Or you can put it 1 over 3 plus 1 over 1, all inverted. It is the same. So you can look for this part of circuit as if it is 0.75 ohms. Now, For the circuit shown, find the equivalent resistance. R equivalent equals, now the 2 ohm and our 0.75 and the 4 ohm are in series, because we replace these two with 7.5. This 2, this is 0.75, and this is 4. 6.75 ohms. This is the equivalent, and the current passes through the 3 ohm. We need the current through the one in the 3 ohms here in the back. First, let's find the voltage here. Let us name this A and this is B. Voltage AB equals the resistance between AB and the total resistance times the total V. The resistance between A and B is 0.75. Total resistance is 6.75 times the total voltage is 27. So 0.75 multiplied by 27 over 6.75 is a 3. So the voltage for the parallel is 3 volt. This voltage through AB is the voltage for the 1 ohm and the voltage of the 3 ohms. I need the current in the 3 ohms here. The current in the 3 ohms equal its voltage over its resistance. The voltage is a 3 and the resistance is a 3, so the current is 1 ampere. It's a very easy question. This question comes repeatedly in exams. Question number 3. For the given circuit, find the current passes through RC, the EMF of the battery, if it's ideal, the rate at which energy is dissipated. Here, we need to find the current through RB and RC and solve the question. We need to make some tricks here. Name this A, B, C, D, E, F. The main current is I. I will name this current I1 and that one I2. Now, from here, we have a parallel. What does that mean? That means BCD equals BEF. The voltage from C to D exactly the same as from E to F because they are in parallel. Now, the voltage through CD is I1 RB in this branch. The voltage through BEF, it is this current here through RC. So I2 RC. It is a very interesting question. I don't know I1, but I know RB. RB it's 25. So here I have 25 I1. I don't know I2, but I know RC. RC is 37.5 times I2. If you divide it by 25, so I1 equals 37.5 divided by 25, it is 1.5. 1.5 I. Interesting. Now, if you apply Kirchhoff's rule, apply Kirchhoff junction rule at point C, sigma in equals sigma I out. At point C, I is in, I1 and I2 are out. So here I equals I1 plus I2. I, it is in to the point C. I2 out, I3, I1 out here. Okay? So the two blue currents equal the yellow one. Now you can substitute for all. I, it is 2 amperes. It is here, the circuit is 2 amperes. Here. I1 from this equation, it is 1.5 I2 plus I2. Then here we have 2.5 I2 equals 2. Then I2 equals 2 over 2.5, which 0.8 ampere. Now you can find I1, because I1 it is 1.5 I2. So it is 1.2 amperes. Both of them add to 2. 0.8 plus 1.2 equals 2, which is the total current. It is a very interesting question here. Now the EMF of the battery. We have a battery, We have the total current, but we need to find the total resistance. R equivalent, you find that 37.5 and 25 are in parallel with 21 in series. So these two are parallel. With that one, we have a series. So first, do the parallel. For the parallel, R between C and D equals RC multiplied by RB over RC plus RB, or 1 over RC plus 1 over RB inverse. So it is 37.5 times 25 over 37.5 times plus 25. The answer would be 15. Now this 15 with 21 in series, so R equivalent like this. This is our battery. This circuit is 21 ohms. This point C and this point is D. We replace the parallel with 15 ohms. So R equivalent equals 21 plus 15, which is 36 ohms. Now BEMF equals I times R equivalent. 2 times 36, it is 72 volt. Can we find it without using this procedure or this technique? Yes, we can solve it by potentiometer. You know I1. from this, and you know RB, so you know VCD. VCD is I1 times RB. I1 it is 1.2 times 25. Add this with 21 times 2. Let me explain myself here. Or this is another way. This is 21 ohms and the current is 2 amperes. Here we have C, and here the current is I1, and RB it is 25. Then here we have like this, here I2, and here RC 37.5, I think. Yes. And here our battery. Now if you find the voltage from C to D and the voltage from B to C, they will add to be the VEMF. The voltage here plus the voltage here equal the voltage for the battery, or there is no resistance here. Now the VEMF should be equal to VEMF equals V from B to C plus V from C to D plus V from D to A. There is no potential difference between D and A because there is no resistance. V between B and C, it is 2 times 21, these two values. And VCD, it is I1 times RB. I1, it is 1.2 times RB, it is 25. 2 times 21, it is 42. 1.2 times 25, it is 30. So it is 72, the same as before. So you can find it without this procedure. The rate at which energy dissipated in RA. RA, it is 21 and the current is 2. So we put in here, I don't need paper. For bar C, power in A equals I in A squared times RA. I in A it is 2 amperes squared. RA it is 21. 2 squared 4, 21 is 84 watt. Last question for this part. Figure shows resistors wired in a combination of series and parallel for a given circuit. Find the equivalent resistance of the circuit. What is the potential drop V1 across R1? Find the current I2 through R2. What power is dissipated through R4? Please practice such questions. All these circuits are the same. 2 parallel with 2 series, 2 parallel with 2 series, 2 parallel with 2 series, but the shape of the circuit different, but it is the same procedure. Now start with a current flowing through the battery through R1, splitting here for R3 and R2. Are R3 and R2 in series? No, because there is splitting here. Are they in parallel? Again, no, because R2 ends here R3 ends here before R4, so they have no common ending or beginning, so they are not in parallel. But if you go to R3 and R4, you notice that they are in series because there is no branching between them. So first of all, here we have a series. I will name it as R5. It is R3 plus R4. R3 6, R4 4, it is 10. Now you can replace this 10 . So here is our circuit. Here R3 and R4 will be replaced by 10, which is R5, 10 ohms. Here I have R2, also 10 ohms, and R1, it is 7 ohms. And the potential here for the battery is 24. Now, it's easily to show that these are in parallel because they have common ending and common beginning. So R2, sorry, with R5 parallel. The equivalent of them is R6, which is the multiplication of them over the addition of them, which is 5. Or one of them over 2 because they are identical, or 1 over 10 plus 1 over 10, all inverse. So you can remove R5 and R7, R2, and put instead of them 5 ohms. So here I have 7 ohms with the battery, which is 24 volt. And instead of R2 and R5, I will put R6, which is 5 ohms. Now it's easy to find that R equivalent is R1 plus R6 in series. R1 it is 5, R6 it is 5, so it is 12 ohms. Sorry, R1 is 7 plus 5 for R6, so it is 12. Here we find the equivalent resistance. Now to find answers for B and C and D, we need to find the currents in the circuit. Here the total current, here it will be split into I1 and I2. Now let us find our currents before proceeding with B and C and D. The total current I equals the electromotive force of the battery over R equivalent. It is 24 divided by 12, which is 2 amperes. Here I can find the potential difference across R1. V1 equals because the current flowing through R1, it is the total current. The one flowing through R1, it is the total current. I times R1, I it is 2, times R1 it is 7, so it is 14. Note that this is part B. Now how can I find the current through I2? Put names here: A, B, C, D, E and F. Now, it's easy to show that the potential through the battery, it is the potential from B to C, then from C to D, then from D to A, as the question before. So here, I advise you to solve like this. The electromotive force equals VBC plus VCD plus VDA. V through DA is 0 since there is no resistance between D and A. The VMF electromotive force for the battery, it is 24, equals VBC, I found it is 14. It is V1. This one is V1, which is 14, plus VCD. Now I have VCD. It is 10 volts, which is flowing, which is across R2 and R3 with R4. Now, if you need to find I2, it is the voltage from C to D divided by 6 plus 4, or find VCD, then find I1, subtract from I, you will get I2. So I1 equals VCD divided by R2. VCD, we find it 10, R2 10 is 1 ampere. Now I equals I1 plus I2. The total current is 2, I1 is 1 plus I2 is I2, then I2 equals 1 amperes. And this is part C. So this is solution for part C. Now for part D, the power dissipated in R4, here R4, power in R4, it is I squared I2. Why I2? Because the current flowing through R2, it is I2. This is current go to the R2. So I2 squared times R4. I2 1 squared, R4, it is 4 ohms. So it is 4 watt. That's it for this question, and that ends the part 4. See you next part.
I hope that this video has enriched you more. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of part 4. See you in part 5. Salam.